systems programming with Rust. Um, Rust, first and foremost, is not a language. Rust is a cult, and y'all are going to be joining today. Just kidding. Rust is a systems level programming language. It is very popular right now. Um, and that is because of a couple of reasons that we'll go through in this presentation. But I personally believe that there are a couple of things that Rust does really, really well, especially when you compare them to other systems level languages, such as C++. Um, if any of you guys have ever worked with C or C++, you may have heard of what segfaults are. If not, that's completely fine, but just know that segfaults are completely impossible in Rust. Well, mostly impossible. Um, Race conditions, if you guys have ever heard of them, also mostly impossible in Rust, just by the nature of how the language is structured and how it forces you to do certain things in certain ways that are arguably more correct, but it does get some getting used to. It takes some getting used to. So, well, of course, here's the table of context for contents for you guys. We're just going to be going over making, we're going to be going over networking, first of all, networking 101. I'm going to introduce you guys to what essentially sockets are, what TCP is, what HTTP is, and then we're going to make an HTTP server. Um, and we're gonna read through the HTTP RFC, and I'm gonna go through that process live with you guys. And also, I'll go over some common pitfalls that you might want to avoid when making HTTP servers. Now, you might think that making HTTP servers is no big deal. React is just one big server anyway, and you guys are just gonna, I don't know, import React and call it a day. But if you're doing systems level work, holy shit, um, you're gonna need to get a hold of your basics. And an HTTP server is pretty much the bare bones of what you're required to know how to build if you're gonna be going into systems level programming. So let's start with Rust philosophy. So why Rust? Right? You're hearing this name pop up everywhere on the internet. You know, Rust this, Rust that, everything that can be rewritten in Rust will be rewritten in Rust. But why? Why Rust? Why is it so damn popular? So, Rust is essentially fearless. So, a lot of common crashes, common bugs that have befelled entire infrastructures for I don't even know countless SaaS companies and so many of these. I think Cloudflare went down quite recently in the last couple of months, and they patched it just by rewriting their whole component that caused them to go down in Rust. And as soon as they did that, everything was fine. Um, so a lot of the common pitfalls that you might have with other systems level programming languages are just not there. And you might think, oh, this is a trade-off. We're trading off one bug for another. If you eliminate one type of bug, another type of bug just like spawns in out of nowhere. That is not the case. Rust, what it does is it limits you into doing certain things, and it does not allow you to do certain things that will cause your code to be bug prone. So Rust is not a lazy language. It will not let you write lazy code. It is very strict. It has zero cost abstractions. Um, it is very high level, but it also does compile down to machine code, to assembly, which makes it just as efficient as C or C++, but not nearly as verbose. Obviously, there is a learning curve. You're gonna have to take some time into developing a sense of the Rust language and a sense of the syntax. Not everything is just the same as you might be used to in Python or C or C++. Um, but um, syntax is just syntax at the end of the day, and you will get used to it. Um, what matters is Rust as a language and as a philosophy is by far the greatest thing to happen in systems level programming in, I would say, maybe the last 5 years, maybe even the last 10. Yeah. Also, the ecosystem is just great. The standard libraries are great. You're not going to be needing external packages, and if in case you do need them, Cargo, the standard package manager does provide a way for you to use certain packages. They're called crates, but you'll get used to the terminology later on. Um, and we're going to be using the standard library package called standard nets, or specifically our HTTP server purposes. So I'm gonna walk you through that as well during the main coding live coding part. Okay, so the borrow checker. The borrow checker is the big USP for Rust. Now, have any of you ever heard of the term the borrow checker before, or are we completely new to this? Let me know. Let me know. Because my definition is gonna vary. Pretty new. Okay. No idea. That's valid. New. Okay. So most of y'all are new to the concept of a border checker. So do you guys know how runtime languages work? Have you guys ever worked with Python or JS? Not compiled languages, interpreted languages to be specific. There is a way to compile JS, but we're not going into specifics here. Any interpret? Okay. So you guys have worked with interpreted languages. Um, why this matters is so common compiled languages will essentially um, there are a lot of compiler bugs in the compilers that you will be using. So let's say, for example, you're writing code in C and you're using the standard compiler that comes with Linux. Yeah, you're using GCC. Well, GCC has certain bugs which, if you write code a certain way, logically it should work. Syntactically, it should work. Like, it should work perfectly. But because the compiler itself has bugs, it's not, it's gonna throw you that error regardless, right? And interpreted languages are much safer that way because they're essentially not compiled, so they don't depend on a compiler. They depend on an interpreter, which runs the code in lifetime. It's gonna give you some runtime bugs in runtime. Why that's who can tell me why that might be insecure, why that might be prone to hacks, or why that might be prone to security bugs. If you're throwing errors and catching errors in runtime. I see some of y'all are typing. It can cause damage before being caught. Exactly. You have something running on your server, and it is throwing a warning. It is throwing an error that you forgot to catch, and someone has already exploited it because it is already running on your server. There's no way to prevent it. What the borrow checker does is it is a thing that runs at comp time, but it gives you those features of catching bugs that you would essentially see in a runtime language. So it gives you the option to throw and catch errors in comp time, which is which is mind blowing. Like it sounds way too complicated right now, but just from a security standpoint, it makes the language itself safer to code in. So if you were to code a certain piece of software in C, and if you were to code the same software in Rust, the Rust the Rust compiled executable would essentially be theoretically safer than the compiled version that is compiled in C. Isn't that crazy to think about? That just by like switching languages, you can make something safer. I don't know about you guys, but that is mind blowing to me, especially from if you're going to be working, industry wide. You're going to be preventing um, a lot of money from being overspent, and who knows, you guys might get raises just because you guys are using Rust, you guys are Rust stations. But of course, with that comes verbosity. So there is this concept of ownership that I'm gonna try to explain right now, but it's gonna be pretty hard to understand. You guys will understand it eventually in the live coding, but just bear with me right now. So ownership essentially means that every resource, every variable, every sort of data entity that you have in your code has one and only one owner at a time. Meaning that you have a string, right? Stored in a variable called x. You can only make changes to x for that to change. So say if you were to say let x equals y, and you were to make changes to y, the borrow checker wouldn't even let you execute that code. That is just theoretically not possible in Rust. You can only make changes to x if a certain data value is in x. So if you guys want me to write the piece of code and explain it to you in lifetime, I could also do that. But for the sake of time, let's read through this right now. I'll explain it in the live coding. Don't worry about that right now. Moving is essentially the same ownership rule, but for heap stored objects like strings. Um, wait, do you guys know about like heap stored and stack stored objects? Do you guys know what they? Okay, perfect. So for objects that are stored on the heap, um, how Rust does it is how Python does it is it's gonna pass a reference. So I'm gonna whip out my iPad and I'm gonna draw this on Notability so you guys get a better feel for what this actually is. Okay. Here. Okay, you guys see my screen, right? I'll just stop the stream here. Okay. I'll just whip out my Apple Pencil and let me switch over to Rust ownership. So for specifically for stack stored objects, Rust is gonna essentially, so if you say let's x equals 5, and if you say let's y equals x, this is gonna, if it's in the same scope, so let's say if it's in fn main, and let's wrap this in here. So you would see here y is equal to 5 and x is equal to 5. And so in this case, x and y both have ownership. This is strictly not possible in Rust. Two objects two stack stored objects cannot have, one object that is in two variables cannot, they both cannot be the owner. There can only exist one owner at a time. But for heap stored objects, because of the way heap memory works, you're gonna need to be creating copies a lot of the time. Because say I have a string, let's x equals string colon from, this is the basic string syntax in Rust. So say I have this string set called hello. Of course, we can't forget the semicolon. Wait, did you guys hear me, or did my audio bug out there? Okay. So say I have the string, and I say let's y equals x. Okay, I don't know why this is, but again, I'm just gonna close this for a bit. Okay, there we go. So where were we? Right. So specifically for heap stored objects, what it will do is it will say this is the borrow checker. Borrow checker. Say y is this new. Is that all of this just hoopla, or for any who don't know what heap storage and stack stored objects are, I'm sorry, but you guys can go over a video later or learn 2021 anyway. So I wouldn't recommend you do that. And then another thing you guys are gonna need to know is referencing. So referencing only happens when the references. Yeah, so a lot of the time when you need to copy something over, and I mean copy in the sense of the word copy, you don't want you don't want x to be let me highlight this. You don't want x to be completely gone. Essentially, what you want to happen is a reference. So what you're gonna write that is essentially say let's s1 equals string hello. And then you're gonna say let's len equals calculate len. This is a function that I'm making up. The spots. Fix this. Whoa. Len. And then ignore this. I'm just gonna put this on the other line. This one. And now you can make a function fn calculates len and then you can pass in as type string. So this, what you're passing in S, let me highlight this with a different color. What you're passing in S is essentially S, a reference to S1. This is what the ampersand symbolizes. And S1 is essentially this whole string. So if you're going to be passing variables to different functions, you're going to need references. You can't do that with variables directly because of how the borrow checker works. Is that clear? Does that make sense? Are you guys with me? Or are you guys not with me? I get some yeses or nos in chat. I'm assuming you guys know how functions work, yeah? I'm assuming you guys know that much. Is that cool? Is that not cool? Okay. Now I'm gonna stop yapping on the iPad. I'm gonna present my screen again. Let's see. Screen. Here we go. So that is ownership to you. And I explained this before. Ownership prevents use after free bugs, which are typically common in C. If you've ever done C programming, if you've, well, I'm not presenting, am I? I'm not. Go. Right. 3 years of professional development, and I still don't know how to share my screen. Okay, there we go. So it prevents use after free bugs. If you've ever used C, if you guys haven't, that's completely fine. But use after free bugs are essentially to do with memory management in C. You guys are going to need to manually free and unfree variables. Because C is primitive, and as Rust users, we hate C with a burning passion. On. So error handling. This is very simple. You guys don't need any code explanations for this. All you need to know is there's no such thing as exceptions in Rust. Everything is explicitly failure coded. Everything that can crash will crash. There's no such thing as error handling. There's no such thing as throwing exceptions. If there is even the slightest chance of an exception, because Rust is compiled and Rust relies on the borrow checker for security, if there is even the whiff of an exception, Rust code will crash. It can be tiresome, but if you need safe code, if you want to learn how to write safe code, you're gonna need to go through a certain sort of ego death, in the sense that Rust will not let certain things slide. That's just how Rust is. It's gonna be frustrating, but it's gonna teach you how to be a great developer. I promise. Or at least so heard. Right, moving on. So a little bit more about what we're going to be doing, what we're going to be making. We're going to be making whatchamacallit, an HTTP server, right? So you guys are going to need to know what TCP and HTTP are to understand what HTTP server essentially is. So are we familiar with HTTP at the very least? HTTP being not the thing that pops up on your URL bar on Google Chrome, but the protocol itself. It's okay if we're not. I'll go over it in just a second. But let me know. I'm gonna need some yeses or nos. Again, completely fine if we're not, but just let me know. I mean, even if you are, there are certain things that I will go over that you guys need to know. But if you guys are, that is certainly an advantage. Okay, so what you made is a CRUD application. if you've made CRUD apps before, you've used HTTP. Do you understand HTTP? Do you know essentially what HTTP is? Like what the definition? Okay, you guys know the definition of HTTP, right? It's hypertext transfer protocol. And it essentially is what it says. It is a protocol to transfer text over the internet. It's just that simple. Now, what protocol means is there are certain rules that you're going to need to follow if you're transferring data on the internet. And what defines that protocol is this thing right here. It's the HTTP 1.1 RFC. What RFC is, or what RFCs are, is, hold on, let me take a sip of water. Okay, what RFCs are is basically a whole bunch of internet nerds coming together to define certain mandates, if you would. Right, as Suzanne's saying, you will get deeper into HTTP. This is a very cursory look. If you guys want to learn more about HTTP, this is where you go. This is where it all started. This is where the internet began, as you know. Right, HTTP. You guys are gonna see a bunch of stuff in here, like, as you can see, this is very, very, very long, very lengthy. We're not gonna read the entire thing. We're gonna read certain things, such as these things. You're gonna need to know what content encoding is, content language, content length. All of these are variables that you need to define when you send an HTTP request through the internet. So I'm gonna whip out my iPad again, like a nerd, and I hope y'all can follow. I'm gonna share screen again, and how do I do this? There we go. Figured it out. 20-year-old man, by the way. There we go. So let's go into a new page here. I'm gonna share all of these pages. So do not be worried. Is it telling me to write in black? What is going on with you, Notability? Okay, we have white back again. So my pen isn't on. Generational oral loss moment, I guess. Anyways, continuing HTTP requests. Why did I write a G? Oh my god. Requests. There we go. So, an HTTP request is essentially made up of these lines. So, it's a get. This is what you were talking about, yeah? The person in chat earlier. You're saying you've made you made some JSON protocol, or you made some sort of API, if I'm inferring correctly. So index.html or whatever URL you have here. And then you have the protocol version, HTTP /1.1, and then you have the host, www.example.com, and then you have the user agent. You guys don't need to know all of this, but if you do, it's going to be a huge help. Because of course you can just look this up, but if you know this, you can whip out an HTTP server on the fly, which is super, super useful. This is how I landed my my third internship, or my third co-op, you could say. Is I had systems engineering under my belt, and they asked me to make an HTTP server in front of them, and There were some bugs, but I did make it. And they offered me the job right there and then. Oh, yippee. And then you have accept language. I hope I don't need to explain this. It's just going to be English for most of whatever you're doing. Or not English, what am I saying? This is going to be en_US. This is how the internet defines it. And then you have accept sets. Then you have some ISO 8859. Some of this bullshit that you guys don't need to care about. Oh, you need to care about this thing though. UTF-8. This is an encoding algorithm. There are a couple, but the most common are UTF-8 and UTF-16. Most of the time, if you're using HTTP 1.1, you're going to be using UTF-8 encoding. So just be careful of that. You guys can't send emojis. You guys can't send Unicode glyphs. All these hypermedia systems. This is just HTTP 1.1. This is bare bones HTTP. So you guys just send plain text. That's all this was made for. Then of course, the second last line is connection. And we're gonna. This is a server. This is not a CRUD app. We're gonna make the connection to keep alive. So the server is gonna stay alive and listen to any requests being made to and from. And we're just gonna transmit them. If they're valid, we're gonna transmit them. If they're not valid, we're gonna reject them. That's all this is. That's all you need to know. And then, very important, very important. A lot of people miss. You need a backslash or backslash n backslash or backslash n. This is what's known as the blank line. If you guys don't include this whole payload, all of this data that you guys have been working towards sending, it will be completely rejected. You guys need this blank line at the end. And then after this is the body. Whatever you're sending. If it's a push request, you're going to send a body. If it's a GET request, you guys don't necessarily need a body. So there's that. That's all you need to know about the protocol itself. I will stop presenting from my iPad now. Hopefully you guys followed along. And I wasn't mansplaining to a brick wall for the last 5 minutes. So, right. Where were we? So presenting my Discord screen. Here we go. Right, so that's everything you need to know about the RFC for now, for this very basic HTTP survey that we're cooking up. I know it seems like a lot, but it's really not. You guys are going to get used to this in no time. So you guys need to know this, and you guys need to know the three-way handshake. I'm not gonna waste time explaining the three-way handshake here. That's basically how TCP works. And we're just gonna be implementing TCP through a library. We're not making TCP from scratch. That is the distinction I'd like to make. We're just going to be using a template of TCP, and then we're going to be making a layer between TCP and HTTP to transform a TCP protocol, a TCP server essentially, to an HTTP server. The TCP server usually exists on the fourth layer, which is the transport layer of the OSI model. And the HTTP layer exists on layer 7. And what we're making today is the bridge between layer 4 and layer 7. We're handling everything about how data is transmitted. Well, we're not handling how data is we're not handling how data is processed. We're handling how the data is just transmitted from a socket to a website. Is that clear? Are you guys with me? Are you guys following? Or was that just a whole bunch of hoopla? Right. It's so great that you guys are following this, by the way. Yeah. I mean, it's kind of a lot. I get it. It was a lot for me at first too. But I'm just gonna have you. Wait, let me do that for you. Why am I being so pretentious? OSI model. Let's look at this ourselves. Essentially, a TCP protocol, which we're using as a template to build an HTTP server, exists on the transport layer. This only manages how data is transported from one user to the other over the internet. Yeah, does that make sense? An HTTP server presents the message. It basically handles how the user is going to send it and the other user is going to read it. Right? Got it? You got it. Perfect. But you guys are going to get introduced to this slightly later on. But it's really not that hard of a concept to grasp. It's just a mental model of where everything exists, systems level wise. So everything below the transport layer is hardware itself. Everything above layer 4 to layer 7 is systems level software. And everything layer 7 onwards is basically front end. It's basically what you see on your computer screen. Right? Got it? Makes sense? Um, right, moving on. Right, deep dive. We already did this. I explained everything to you. You needed to know about the HTTP protocol on my iPad. I did it a little bit early. Apologies for that, but basically everything I just did on the iPad was everything that you needed to know about the deep dive. But we're just going to go through that again. The first line is a request line. Right? We saw that, and then there are the headers. The headers are the host, the user, the accept headers, and then the connection, and all of that. And then you have the terminator, which I explained was very important. Slash r slash backslash r backslash n backslash r backslash n. This doesn't mean anything. This is just convention, but you need to have this. If you don't have this, everything is going to break apart and everything is going to collapse, and it will be your fault. And then the body is optional, only used in post requests. All right. Status line. This is what you're going to see on your terminal. This is going to tell you if your HTTP server is working or if it's not working. Right? If the error code is 200, okay, it does work. If it's 404 not found, it doesn't work. Pretty sure everybody gets this. Why am I explaining this? Right, content length. This is the most critical header. That's right. But we'll get the hang of this during the live coding. Don't worry about this for now. Why is okay? And then we have the payload, which is the data, the request data that we're actually sending across. So this is not the body. This is the entire request itself, boring the headers. This includes the tail as well. This includes the blank line. But that's basically just how the HTTP request is structured. What we're gonna be building is we're gonna be building a server that takes a TCP request from a TCP socket, and we're gonna build structure around it. Right. So it's officially been 45 minutes. I've been yapping about Rust nonstop. Hopefully you guys followed. Hopefully it all made sense. What we're gonna do now is we're gonna be live coding the server. So this is the interactive part that y'all hopefully have been waiting for. But we're gonna need to stretch our fingers and we're gonna need to get coding right now. Hopefully you guys already get cloned the repo that I asked you guys to clone beforehand. If you guys didn't, you basically just actually let me see yeses or nos in chat to whoever did it or who didn't, just to see how many are still following. Okay, you guys did it. Yeah. So I'm gonna need you all to whip up your terminals. I'm gonna need you all to navigate to the directory itself. Um, and you guys have Rust installed, yeah? Yeah. You guys can check if you have Rust with the rest of commands. Okay. You think it's working? Okay, not this. This is the end product. What I asked you to clone before was just okay. I can just ls here, and you'll see. So if I go into my Rust file, it just says print ln hello world. Yeah, you might have cloned the wrong one. It's okay. You can still keep this. Just make sure to clone the other one as well, and then go into that directory. Like open that using your VS Code environment. Okay, good. Are we on the same page? Yeses, nos, maybes. And some responses. I will then move forward. Okay. How about the others? Great. Y'all are following along. So what we're gonna need to do now is hold on. Yeah, okay. We're gonna go into our src/main.rs file, and we're gonna keep this main function. We're gonna at first import some libraries that we're gonna need. So actually, let me check if I have Rust Analyzer on. Oh, there we go. Rust Analyzer is a fancy LSP that you guys don't need. I'm just checking if I have this on. If it's gonna cause me issues. I don't. Great. So we're gonna have nothing interrupting this experience. You guys can use it. VS Code will recommend that you install it, but for now, because we're beginners, we don't want to rely on any LSPs or any external tools for now. So we're gonna import this library, and then we're gonna import standard IO. That much should be self-explanatory. But we're only gonna use certain items. We're not gonna import the entire library. That is not in the spirit of Rust. We want to keep code concise, we want to keep code tight, and we don't want to introduce any security bugs. Use standard net. Okay, this is what I told you guys about. This is the library we're going to be using, and we're essentially importing a whole as TCP server from Rust's standard library. We don't need to make this. How neat is that? Basically like importing libraries in Python, but Rust has everything in a standard library. It's not nearly as insecure as Python is, as JS is, because NPM, I mean, it's like if you've worked with JS before, NPM is just a complete, like, pardon my French, but it's a complete shit show. Um, right, moving on from my hatred of NPM, we're going to define what's known as an enum. So, important concept here. Um, Enums are basically custom types. So, types like int, int32, int8, int64, strings, lists, um, arrays. Um, if we want to be a little bit, if we want to be a little bit fancy, which is what we're gonna be this stream, because we're fancy guys. Come on, we're using Rust. Can we get any fancier? Um, we're gonna define our custom types for when our HTTP server is actually alive and when it's not. Does that make sense? Because we don't want error code to be 0 or 1. We want it to be okay or not found. That's basically it. That's basically all I'm doing. I'm basically just making a Boolean type to tell me if my server is responding or if it's not. Hopefully that made sense. Keep letting me know in chat if you guys get stuck anywhere. Of course, if it's a longer question, I'll take it up in the end. But if it's an immediate explanation, I'll try my best to explain it to you right here now. So now we're gonna be writing an implementer. What this basically is I forgot the name actually. That's embarrassing. Let me search up what are those called in Java. I know I studied that too. They're basically like you can't make objects of that class. You can have an object inherit that class. I forgot. Inheritance. It's called. What class can you not make an object of this up? Abstract? Yes. Yes, you are correct. This is basically like an abstract. Not completely. I'm grossly oversimplified. Interface. There we go. That's exactly what I was looking for. Thank you, Chatter. This is not exactly, but basically like an interface. What we're basically going to be doing is we're going to be linking our enums to actually respond with the appropriate HTML link. So this is going to get a lot easier if I just write the code and shut up. This is what I'm going to do now. Self. Of course, we're going to need to pass self because we're doing a little bit of object-oriented bullshit. But bear with me for a second. str and str. So we're going to be passing two strings in here. And what those strings are is you're gonna see for yourself. So, right, the match statements. I'm gonna help you guys understand this as well. Match in Rust. Google's gonna do a better job of explaining this. Then I will. Right, the match keyword is used for matching. So it's basically just a way to concise. It's basically a mixture of try-catch blocks and if statements. It's basically if statements were try-catch blocks. Does that make sense? Like, you don't need to nest if statements to. So I could write this into my editor again. I could write this as a if HTTP. I'm just writing pseudocode here. Response equals okay, then you do blah blah blah, and else if HTTP response equals not found, then blah 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 blah, and then else return 0. Right? We're not doing that. We're not like it's just a lot of verbosity for no reason. Match statements just make it easier. What we're gonna write in the match statement is if HTTP response is okay, then we're gonna say link this to, we need a string here, HTTP colon 1.1 200. Okay, do you guys remember this from what we just covered? Yeah, we're passing the okay status code from the protocol directly as a string. So the protocol knows that this is an okay, when I'm using the okay enum, this is an okay request. And the server sends me over to this URL, which conveniently I made for you guys already, called hello.html. So if our server is working, it's going to send us to hello.html, and holy shit. There we go. If it's not, it's gonna, what is the file in? We're just working inside of main.rs right now. So src/main.rs. You guys can see it over here. If you go into the repo, if you copied it correctly, you go into main.rs, you're gonna start from scratch, but hopefully y'all are following along, because I will have a hard time repeating all of this. Not found. There we go. Hopefully you guys got the point already. And now we just need to do the HTTP 1.1 or 4 not found. Holy typos. And then this is going to link to 4.4.html. And if you guys are curious, so this is, we're in the SRC file right now. If you guys look at the whole Git repo, this is where the 4.4.html and this is basically the 4.4.html. And what is, okay. And then this is hello.html. It's basically just boilerplate HTML code, nothing specific. But basically just to give you an idea of where we're going with this. So, okay, now we have this abstract class set up. Now, no more object-oriented BS. We're gonna get straight to business. So we're gonna remove this print line, and now we're gonna attempt to bind the port to a TCP listener. And from the listener, we're gonna allow in data. So how we do that is to say let listener. Okay. There we go. So we say let listener equals TCP listener colon bind, and we're gonna do the basic localhost URL, which I hope all of you know by now. And we're gonna use port 7878 because that is just how I configured it, and that is what the what do you call it? What should we call it? That is what the convention is. So you guys can make up your own numbers and lick them, and it should work the exact same way, whatever port you're forwarding it on, as long as it's not in use, which it should be, because you have thousands of them. Right, and this dot unwrap statement, you're going to be seeing this a lot. What this basically does is tells Rust that unwrap means if okay, then move on. If not, then crash and give diagnostics. That's all unwrap means. So you're going to be seeing this in every line that can error because we don't want Rust program to crash and not know why it crashed. Right? I told you this language is going to be slightly verbose. You guys are going to get used to it. Fine. And now we're going to say print ln. Then we're going to do bang because it's a macro. You guys are going to learn about macros if you read the book. For now, you don't need to know about them. Right. We're running on http://127.0.0.1 7878. This is just console output to tell us that, oh, I missed a couple of, where am I going? I'm not here. And did I miss any semicolons? Hope I didn't. Okay, I found, yep. This all looks fine. Okay, this looks fine. Hopefully no errors. And now we're gonna run a for loop. For stream in, by the way, I hope you guys can appreciate how high level the syntax is and simultaneously how much lower level we're actually going with this. Like, if you guys attempt to do this in Python, it's gonna be like, I don't know, 7 million times slower, and I'm not even exaggerating. It is literally gonna be 7 million times slower. And if you're gonna do this in C, it's gonna be like equally as fast, but like 10 times more bug prone. So Rust is literally a blessing by the gods. If you guys are gonna do systems level programming, if you guys are gonna do network programming in the future, if you guys plan on having that job stream be open for you in the future, you guys are gonna have to learn Rust. Like, Rust is no longer optional. That's how serious this is. So let's get back to the code. Stream equals stream.unwrap. Here we go. You see the unwrap again. And some mosquitoes bothering me. All right, give me a second. Unwrap, and I put a semicolon there, and then we're gonna pass it to handle connection string. Now, if you guys have this on VS Code, this is already gonna throw an error, but don't worry. The word checker is just ANSI. We're gonna make the function right now, and we're gonna make this mutable. Oh, right. Did I talk about Rust variables being immutable by default? Give me a yes or no in chats. It's pretty much a topic. If we've already covered it, that's awesome. If we haven't, I'll just cover it right now. But you guys are gonna need to give me a yes or no for that. Didn't? Okay. Basically, Rust is so strict that when you define a variable, let's say I said let listener equals TCP listener. Why is this? Right, $sign, no, stupid. This whole variable, it cannot rewrite this by default. This is like Rust by default is operating on const. Like, every variable you define by default is a const. If you want to be able to change it in the future, you're gonna have to make it mutable explicitly. Does that make sense? This variable is basically a const. You cannot change it. if you want to be able to change it, you're gonna need to declare a mute and say to the Rust compiler explicitly that I want this variable to be changeable in the future. Does that make sense? Yes or no? Because I will be moving forward. I don't think it's that hard. The concepts. Okay, makes sense. Perfect. So buff reader. Don't worry about what buffering is right now. What you need to know is instead of sending data into the stream, let's say we have the stream here. So let's say I can send the data first. I can send H and then send our streams handle connections is I would send H, then I would send HE, then I would see HEL, and then I would see HELL, and then HELL. We don't want this happening. This is stupid. So what we're doing is we are chunking data into 8-byte blocks, which is also known as a buffer. And we are sending eight 8 bytes worth of data every tick. So if I were to send hello, my name is Gurnoor, I would first send HELLO. That's 5, right? Yes. 6, 7, 8. And then I would send HELLO. MY space, so this is 1, 2, 3, 4. It's 5, right? Yeah, 6, 7, 8. And then basically the rest of my name. Because my name is 7 letters and this entirely would be. This is what we're doing now. This is way more efficient than what we were doing before. Like strings in Java. Sorry, I didn't catch you earlier. What do you mean by like strings in Java? What question were you asking explicitly? I'll try my best to answer. Basically, that's all buffering is. So we're chunking data, and we're saying buffer reader. We're gonna make a new buffer reader, and we're gonna pass in the stream. So we're chunking everything that we're passing through stream. And sorry, I'll slow down if you need me to. If you have any questions, feel free to ask. That's all I'm here for. Right. Seems like question is already resolved. So we're gonna move forward. We're gonna make a lecture request. We're gonna make a vector. So a vector is a dynamic array in Rust. It is basically like a Python list. So it is a list of dynamic length. An array of dynamic length. What that means is we're not limiting the length. The length is essentially infinite and it is being stored on the heap. That's what vectors are. But reader lines map. If you guys are confused by any of these functions, I recommend that you go through. You can just ask ChatGPT, or if you guys are old heads like me, you could read through the Rust book. And that would make sense to you. But if I start explaining all of these Right now, this code is going to take a lot longer than I intended it to be. So if some of this is slightly confusing, don't worry. You guys can figure this out on your own time. Let request line equals. What is that character inside map? That is your backslash symbol. If you just press shift and type that, that is basically just that staining glitter, and that's an L inside of that. Hopefully that makes sense. Request 0, so we're basically reading the first letter of the request, and then we're gonna status equals if request line equals get. This is basically we're reading the first line of the protocol that I explained earlier, which is get slash HTTP. If you guys remember, I explained this whole thing earlier on my iPad, yeah? This is just the first line, which is what the zero symbol right here means. We're reading the first line of the request because we're chunking data and we're passing it to the vector line by line. So what request is right now is just an array of this is line 1, this is line 2. We basically split the entire request into chunked lines. Hopefully that makes sense. So we're gonna pass it to response. Okay. Else. On the side here. We're gonna say else. HTTP response. Colon not found. We're saying this is what our status is. If the first line is get slash HTTP 1.1, then we need to pass the OK enum. And if it's not, we need to pass the not found enum. Now this code looks like it should work, but it will not. And I will demonstrate that right now. So we're going to save this and quit. And we're going to say cargo run, not inside of here, right, inside of here. We're going to say cargo run. And you see, the world checker is going to throw an error because I did something wrong. Not part of the script. So let me check where I made a mistake. Unused import. Okay, we can just remove that. And string is not an iterator. Right. Right. That makes sense. That makes sense. That makes sense. Oh, so I missed something. We're gonna go inside of with me. I go inside of here, and we're gonna check if we did wrong. Right. So we said this is an unused import, so I'm gonna remove that. And that's did we do that? No connection. Right, we did that. Sorry guys, skill issue here. Okay, let me check this should run. Has a problem with dot collect. All right. Let's see what I did. Sorry, guys. I made an oopsie. I wasn't supposed to make. This is supposed to go outside of this. Let L dot unwrap. We're gonna throw in this here, close this, collect. There we go. There we go. That's how we debug like professionals. And now we're gonna cargo run. So code is running. Um, it's giving us some warnings, but we're gonna ignore them for now. We're gonna go to our Rust server, and it's loading, it's loading, it's loading, and it's gonna keep loading, and it won't stop loading until the end of eternity. Who can explain to me why this is? I'm gonna wait a minute, and then I'm gonna move on. Nobody? I don't blame you. So what I did was I made a common beginner mistake, which is essentially, we'll explain this right now, inside of this server. Basically what I did in handle connection is I made a request and I did everything correctly except I missed an exception where if if a client keeps sending me bytes, I'm never closing this connection. I opened this connection over here, and I passed it to handle connection, and I never closed it. It's just gonna keep running until eternity, and it's gonna wait for me to close it, but I never close it. It's gonna be, it's gonna just like, it's just gonna keep running until it dies, is what it's gonna do. So what we're gonna need to do to fix this is, instead of request being a vector, we're gonna say this is a request line. Okay, yeah. Instead of this being a vector, we're gonna delete this. Right? Am I right? Am I? Yeah, we're gonna delete this, and we're gonna say this is a buff reader. We're gonna remove the vector type, and we're gonna say it's line. So this is just a regular string of bytes now, and we're gonna say lines, and we're gonna delete this. We're gonna say next. Unwrap dot unwrap. So we're gonna double dot unwrap this. Is buffreader can throw us an error, and then buffreader dot lines dot next can throw us an error. And so that's where we're gonna need to double unwrap this, and this should now work accordingly. We're gonna move on because I'm slightly lagging behind here, but hopefully you guys get the point. So this is okay. Right? And then we're gonna say let status hold on. I'm missing something. Right. Right. Okay. That makes sense. That makes sense. That makes a lot of sense. So status so we're gonna change some things on the fly here. I'm just gonna give you guys the code, and I'm gonna show you guys common mistakes at the end. So we're just going to type this all out collectively. And if we're finished by this in the next 10 minutes, I'm going to show you guys common beginner mistakes. I'm not going to live code them because it's going to be an extra 30 minutes, and I would rather not keep you all here for that long. So where were we? Right, so we were at let's. Right, so we're going to define a tuple here. That is line. We're going to say file name is the other variable we're going to be passing, and then we're going to say response type. So response type, whatever response we're getting from the stream itself, we're gonna pass those details into the variable status line and file line. Because those are the two details that this function is going to be passing us. Right, so now that we have that, we're going to say let's contents equals fs. Right. This is where we're going to need that line here. Use standard fs. I removed this earlier because this was an unused import, but now it is not. So we're going to say let contents equals fs read to string and what else were we saying? Read to string, yeah, and then we need to pass read dot to string. What am I? What am I doing? Losing my mind here. Writing Rust. Right. And now we're going to use another type, unwrap. We're going to use unwrap or else to say that don't crash it if this returns an error type. And we're going to pass in a null object here. So we're not passing anything into the unwrap or else condition. We're just saying if it's an error, give us string colon from. Right. Oh, I made another mistake. We need this to be down here. We need this like this. Now we're gonna say. Now we're gonna say string colon from. Then I'm gonna say we're just gonna change the h1 on our HTML file, and we're gonna have it say /4 \h1 / oh, no, so let's do it first. I'm actually losing brain cells. What a thought. He using a paragraph tag here. Resource. Not like that. There we go. So essentially what we're saying is wrap this. If it's an error, make us read us this message. If it's not, then it's just going to let us go on to the regular hello.http, which is exactly what we need. Now we're going to say let len equals contents.len. Reminder that I told you guys that contents.len is the most important tag that the TCP server or the HTTP server is going to be passing us. We need to make sure that the length of our request matches the content length. If it doesn't match, it's just going to request. It's just going to reject the request. But we're going to make it so that it possibly can't send a length that is not identical to the length of the contents. And we're going to be doing that like this. So we're going to say let response
equals formats. And this is a macro. You guys don't need to know what that is yet, but if you guys are interested, again, go read the book. That is the best thing that you can ever do when Rust is concerned. We're going to say backslash or backslash n, and we're going to say content length. We're passing this in the exact format that I explained on the iPad earlier. And backslash. And then this is where we're going to be ending with a blank line, so you guys know what's up. Backslash or backslash and backslash or backslash and like a caveman, but overlords demand that we do so. We really can't. We really can't complain. Sorry, this needs a regular bracket, not curly braces. And semicolon. So we're making this the request, and we're passing in the exact content length that we saved here, and these are the contents that we're passing, which is exactly what we defined. Great, moving on, and then all we need to do here is stream.write underscore all. All right, I forgot to monitor this. If I remove any one of these, I just leave it at backslash or backslash n, and I wrote all this. I should, what am I? I should show you guys the correct code first, so you guys know what mistakes you are prone to make. Better. Because otherwise it wouldn't make any sense. And I don't know why I thought they would. So basically, we're just telling the stream to write all of the response as bytes. So we don't want to pass strings into the response. The response is going to be bytes. We're going to be passing bytes through the server, raw data essentially, and we're going to end it with a dot and wrap like this. Stream can close the stream can and throw an error. If it throws an error, it's just going to crash, and then I'm going to say stream.flush. This is also really important because after it sends a request, we're going to need to clean up the stream, or it's going to essentially jumble the previous response with whatever new response we're going to send. And that's going to cause issues with the content length. That's going to mess up the protocol. And without this, the request is just going to be rejected. So, keeping that in mind, voila, this is it. This is it. This is it. You're done. You're done with the entire server. Let me get some. Let me get some woohoos. Let me get some celebrations in the chat. That's it. That was the entire thing that you needed to do. I'll even demonstrate with a cargo run. Never mind. I am brain dead. TCP stream, this delimiter might not be properly closed. A bit early for celebrations. It seems I made an error at line 30, but we're gonna fix it right now. Forgot to close a bracket. I forgot to close a bracket. That is as standard as errors gets. Right. That's fine. That's fine. That's fine. That's fine. That's fine. Oh, see. This is where I messed up, gang. Gang, come on, gang. You guys are supposed to catch that. String firm. Yeah, I need to do this. And we should be set. I'm not gonna embarrass myself again. Never mind, I embarrassed myself again. What is up with me right now? Let's see. We messed up somewhere else. So we're gonna check every single line. What line did it say? Line 41A. Line 41. That's exactly it's. There's no opening bracket for the closing. You might be right, chatter. Where is it? You are so right. So let's see where I forgot to open a curly bracket. I'll handle connection. Close these, close these, close the else one. Right. Yeah. Yeah, this one has a thing, right? Yeah, has a thing. And I never opened a curly bracket here. Right. This is why you should avoid being brain dead when you're nervous. Response type details not found in scope. This is what I meant, chat. This is what Rust will literally cook you. If you basically breathe in the wrong direction. I'm gonna fix all of this. Don't you worry, chat. Don't you worry, chat. We're gonna be fine. We're gonna be fine. Might take an hour, but we're gonna be fine. Just kidding. Error line 37, responsive details. Line 37, eh? Ah, I see. I see it all now. Responsive details. Tuple is throwing an error. Well, that makes no sense. MC status line. Response underscore type details. Contents wrapper else. Status dot details. So it should be response type. Although let's might be in the for loop here. Status equals. There we go. Got it. If response type. You might be right, Chatter. No. You weren't exactly there, but you were there. Kind of. But this is the type of shit that you shouldn't be doing at 2 a.m. Because you're gonna make a fool out of yourself. DFS. What is happening? I made a syntax error in package. Oh, unused import. Oh. Wait, but I used it. I used it. What do you mean? What do you mean? See. What line is it even? Oh. Not when warning emitted. Oh, line 35. Ah. I mean, it's cooking me too, brother. You're not the only one. I'm getting live grilled here in front of everybody. Let's see. Oh, response type equals. What am I doing, chat? What am I doing? Actual Rust moment. Status not found in scope. All right, because we changed the variable name. We're not using status no more. We're using status line. There we go. Cargo run. Okay, y'all can celebrate now. Y'all can celebrate now. After a lot of blood, sweat, and tears, we're finally up and running, chat. We're finally up and running. Let's fucking go. Let's go. This is what we've been waiting for. All right, that's gonna be it. But just for the sake of um teaching y'all something, say I miss a backslash n here. And I run this again. This is gonna absolutely get obliterated. You see what I mean? Can I get some? Can I get some yeses? Can I get some nos? Do you see what I did there? I removed. Hold on. Let my thing breathe. I removed a single backslash n. My request got rejected, and I got nothing over here. Does that does that error make sense? Yes? No? Anyone? And now as soon as I fix it, oh, and I run the thing again. Excusez-moi. Cargo run. And I get the thing again. See? This is the importance of a single tag in the headers. You cannot miss anything. You miss one thing, your entire request gets obliterated. And last thing I wanted to teach y'all is if you don't flush the thing, and I cargo run this again, this whole thing is gonna right. So it's working fine now because of how we've made this. Because we're passing a single string right now, this. But if I were to pass another request without this line, this whole server would crash. So let me stop yapping now. Y'all hopefully have the code to yourselves, and hopefully, hopefully y'all aren't as dumb as I am, and you'll actually ran your servers before reloading your page. You guys should have the whole HTTP server up and running. Congratulations, you guys learned something. And now I'm gonna go back to the presentation. So I'm gonna recap everything we did. So step one, we made the TCP listener, which is what we did over here, and we passed the stream to a handle connection port, and then we used an incoming Rust, whatchamacallit, iterator. We used an iterator to essentially, where's incoming? Let me look up incoming. We used an iterator to pass chunk data, chunk strings from our TCP request to the stream variable, and then we pass them to the TCP listener. Then, oh, and we looped it because we're going to need to do that again and again because we're running a server again. The server is going to stay alive, and for every request, we're going to need to keep looping it again and again and again. Right. Then we're passing the raw streams one byte at a time. Well, not exactly one byte at a time because we chunked it, we buffered it. And that's exactly what it's saying. I'm a dumbass. It's saying reading one byte at a time from a network card is slow and expensive for the CPU. So we chunk it, we buff it, and then that lets us run through the code more efficiently. And then the lines iterator is a convenient way to read the request until the first new line. So that's how we pass the whole request as a string. We broke that down into each individual line, and we passed that vector essentially. And then we used a max statement, which is what I showed you guys here, instead of an if else statement because we're actual Rust devs now. We know how to use Rust and we know how to do things efficiently. And then, right, I showed you the security checks. I showed you the common mistakes. And then we use the format macro. Um, right. If you guys security check, let me show you guys this security check again. Right. It's this loop that I was talking about. I was right. So when we use this unwrap or else here, this is essentially the basis of our security in this entire piece of code. Is just one dot unwrap or else command. That makes our code way more secure, and it essentially says if you found exactly what you want, then accept it. If not, crash it. There's YOLO and VBall, and Rust, by the way. I'm just yapping. I'm fully yapping this one. Um, but yeah, so we use the format macro in that line that we just showed you to format our strings into pure bytes that we need to be passing to the server, and yeah, that's basically it. And then we flush the buffer. So we ensure that the buffer is actually pushed out to the hardware, and that is the end of our code. That is that is it. Um, and I showed you guys some of the common beginner mistakes. I showed you guys the hang time error. I didn't get enough time to show you guys the infinite collector because that would have taken a lot of time. But you guys, I have that code pushed up to the repo. If some of you want to take a look at it, if not, it's completely fine. Not mandatory at all. I showed you guys the panic button, um, in which you forget the sorry, I showed you guys the panic button where it no, I showed you guys the infinite collector. I didn't show you guys the panic button. The infinite collector was just when the thing just infinitely like was loading, didn't didn't even like process the thing, right? We didn't even get to see the browser. We didn't even get to see the web page. That was the infinite collector. The hang time, we forgot one backslash n. We changed one of those, and we didn't get to see anything on the server at all. The server was there, but our request was just simply. And last thing we covered was forgetting to flush the buffer. That is going to be more explicit if we were passing more than one string. But for the sake of simplicity, I didn't want to include two we're going to go a little bit beyond the basics here. I have included a code file, which I will show right here. If I go into Rust HTTP server and I go into src concurrency.rs, this whole thing, yes, I AI this, but it basically takes our thing, our whole code, and all it does is it moves all of our streams to individual threads. So, say we were passing more than one stream at a time, which is essentially what you're going to be doing at industry level, SaaS level um, code bases. Um, you're going to need to be handling a lot of requests concurrently. And for that, you need to be moving each individual thread to each individual request, each individual stream to a different thread, so that everything happens concurrently instead of individually. If you guys have any doubts about that, I'm gonna clear those up. Don't worry about that. In the Q&A section. But that is basically it. So for now, right now, our server can only talk to one person at a time. It can only process one stream at a time. If we use the standard concurrency library, which is called standard thread, we can implement a concurrent HTTP server, which is what is used by and large in the industry. And why this works better in Rust than every other language is and I mentioned this at the start of the stream as well. that in other languages, sharing data between threads causes data races, which is when two threads are concurrently running, one thread finishes up faster than the other one. So it makes the computer think that you are able to take the next stream, the next request. But if one of the threads isn't finished, then it's gonna mix up your data. It's gonna mash up two requests and it's gonna output gibberish. And it may even crash your server. But Rust won't let you do that because Rust has the power checker. So Rust, the language itself is inherently more secure. And that is going to be it. This is where I'm going to be starting the Q&A. So if y'all feel like you need to dip, you guys can dip. Um, thank you for attending the session. Thank you for all your feedback. And thank you for learning Rust with me. And if any of you have any questions, you guys are open to unmute yourselves now, and you guys can ask me anything. All right, go ahead, guys. You guys should be able to unmute now, by the way. Or if one of you has a question, let me know and I'll unmute you. Or Yazan should help. Should be able to help with the thing for you guys to be able to unmute yourselves.
Yeah, I got it.
But yeah, this is basically the informal end. So if you want to leave, you can. I mean that's valid.
Yeah.
I feel like that's fair.
Sorry, could you guys
Um,
unmute, or are you guys having?
But yeah, Rust is
Yeah.
is very complicated. I Yeah, I don't even know what to say to you, man. It's just, I mean, the language itself is like hard, but that is why it's popular. Like, that is why it's like by far and large the best systems level language. Once you get a grasp of some of the concepts that I explained today, and once you get a grasp of HTTP servers in general, I would recommend that you make an HTTP server in at least one other um, systems level language. If you are interested in systems level stuff, which is essentially why you would need to be interested in Rust. If you don't want to do systems level stuff, it's like you're chilling, right? But but what was I saying again? Yeah, if you are interested in it, then I would recommend you write an HTTP server in C or C++ first, and then rewrite it again in Rust and see how much easier Rust makes it. Like it makes a world of difference. What other projects would I recommend? So an HTTP server is like the bare bones. That's where you start. And then if you want to do more, you guys should get a mini computer. So either you should get a Raspberry Pi or something, or some equivalent of the same. I think in if you take 2101, you're going to be doing some um, embedded programming on an ESP32. So if you can start building software, I think the primary language you're going to be using there is C, but there are Rust ports for it. If you want to do more Rust stuff that actually feels fun and it's not just like what I just did today, which is basically just a lot of theoretical garbo. If you want projects that are fun, definitely look into tinkering with an ESP32 or a Raspberry Pi. Write software for that, see how where that takes you, and then you can use the same thing to write kernel level software for a Raspberry Pi. So there is a um, very famous YouTuber called Low Level Learning, and he has a series on this is how I got into um, I got into systems level programming in the first place. I will post that link in general itself. Uh, Low level learning,
I already did it though.
kernel in Linux. There you go. So you can actually do Linux kernel development on a Raspberry. Doesn't that just sound completely insane? I will. I will post a link to this, dude. I'm telling you right now, this is the perfect time to escape the web ecosystem. Because GS is like so bleak. Sorry, this is another YouTuber. I kind of got sidetracked. I'll post the full link here to. Um, so these are two links. Yeah, especially with vibe coding and stuff, it's like it's getting so oversaturated that there's like I'm pretty sure in a couple of years it's gonna get the industry's just gonna get sick of AI pull requests, AI contributions, AI open source. I've read so many articles about like people getting pissed on what do you call it AI PRs being passed to open source repositories. Um, but yeah, people are just getting sick of like web dev and AI stuff in general. This is the best time to get into systems level programming. So you've been tinkering with C++ a lot. That is great. So one thing I would recommend before diving into Rust is definitely do a little bit of C or C++. So what I did was I made a garbage collector in C for C itself. Um, and oh, that's did you do the same thing? Did you look at the boot.dev course from TJ? Dude, that's exactly what I did. So essentially, I learned how to make it, and then I made it. We created it in Zig, um, and then once I did that, and I understood how basically memory management works, I moved on to Rust, and then I did the same thing in Rust, and I was like, holy shit! Like, is this easy? Yeah, like the course is great. TJ is yeah. I'm gonna link the course right here. I think it should be free. Boot.dev is free, but there is also, if you want the interactive elements, um, it is going to be a little bit. You guys are gonna have to pay for the interactive stuff. But if you just want to look at the course itself, yeah, there you go. Someone touched it. If you just want to look at the course, you can look at it on YouTube, or you guys could follow it right here on boot.dev. So there's that. And yeah, it's a great course, great way to learn low-level programming, learn C in general, which is how I learned C back in the day, which was like a year ago at this point. Um, and then I realized how much of a like how easily you could like shoot yourself in the foot using C, more so C++, but also C with like all those use after free bugs and all that like pointer madness, which you're gonna get some of it in Rust too, but for the most part, Rust makes it a lot easier. But yeah, if you're already in that far deep, definitely recommend looking more into Rust, doing some projects in Rust. Just do the same thing. Just do the same thing. Make a garbage collector um, in Rust, and you're gonna realize how easy your life gets, especially with all those mallocs in the freeze. Like it's gonna be a world of a difference. I'm not even like underestimating how easy Rust makes it. So that is awesome about Rust. I know this is like starting to be a little bit of a Rust Blaze session, but I would assume that's what we're here for. So. Also, a mosquito kill counter, by the way, guys. I've killed like 5 mosquitoes in the last 2 hours. It is insane what I'm going through right now. But yeah, made a simple card applicant because your visibility when applying to go up, you were not very successful. Dude, if you are interested, go for it. If you thought this was if you thought this was in any way, shape, or form interesting to you, definitely go for it. But if this just felt like mumbo jumbo, if this felt like very confusing in the sense that it discourages you to pursue it, then like if you don't have the right motivation for it, I mean you're gonna have a tough time, my dude. Like you can't force yourself to learn this stuff. If you're truly passionate, I would definitely recommend just go for it. Low-level stuff are one of the fields that no one wants to do. So there are a lot of people who want to do it, but because of the learning curve and because I mean the effort in it is like massive compared to just web dev. And getting good at low-level stuff is gonna take you a good part of a decade. Like you're not gonna understand most stuff unless you're truly in it for the love of the game. And if you've been like actually making low level stuff for like a good part of a decade, um, you're enjoying learning assembly. That is crazy. If you're enjoying assembly, you're gonna love this. I mean, you're gonna love this stuff. So definitely recommend looking into more C stuff, looking into even open source repos. Like you could contribute to, say, VLC. You could contribute to the Linux kernel itself. You could contribute to FFmpeg. You could contribute to WebRTC with Rust. Yeah, and I would say even if you aren't going into low level, like if you don't plan on going into low level stuff, it's still very beneficial for you to learn low level stuff. Just because it makes your life a whole like you just understand computers better. So if you understand computers and how computers actually work, of course you're gonna understand web dev stuff too. Like what I just did right now is web dev. But I did it um it is both systems level programming and web dev. There's a little bit of web dev in there too, but I'm definitely not doing conventional web dev in the sense that just whip up a React server and then add like 4 components and you have a website ready and then you can just sell it like for a B2B SaaS. No. We're in it for the love of the game. We're actually understanding how data moves through the internet. Like to me, that is fascinating. And like if that is interesting to you in any way shape or form, definitely go for it. Like it is one of the most lucrative fields. You can make a lot of money in low level development. And oh, you had the Verilog version. Yeah. I had the ESP32 version of the class. Like we didn't use Verilog, but I don't know, man. I don't know why, but yeah, they completely wiped it out. And I mean, I don't know, man. I never experienced Verilog, so I don't know what that's like. So basically, they just give you an ESP32, and you write C code, and then you link it to basically you have C and assembly, You write assembly code, you link it to C code, and then you compile it on the ESP32. So it's basically C plus assembly. Um, but yeah, I got completely cooked in that class. But that's mostly because I have insane ADHD and I don't do well academically. But yeah, this stuff is like wildly interesting. So, like practically speaking, if you guys want like work experience in it, then
I just realized
definitely
I can
go.
unmute.
I mean, yeah, I was waiting for you to.
Yeah, I want to add something about about 2021. So like if you're really into that stuff, you can take like in CS, like you have the ability to take like electives that you want. So like classes like digital block design, embedded systems are a good place to start if you like that stuff.
Yeah, there is a 3,000 level course for embedded development as well, right?
Yeah. But honestly, I would like mostly do the learning on your own because like you can't really guarantee a class will teach you anything, or at least will
Yeah,
teach you
dude.
the right stuff.
Yeah. The class was all like we were writing Risk V assembly, which was like, first of all, like
Yeah,
I've written
3215. Yeah, you're
like
right.
Linux assembly my whole life. Like it's gonna take me a while to understand like Risk V syntax and how everything works. And yeah, that just threw me for a loop. Um, sorry, that's just I'm just yapping.
Yeah, I'm just talking. Yeah, it was 3215. It was pretty useless. Oh, that's not good.
That sucks, man.
Yeah, yeah,
I'm sorry.
exactly. Yeah, learning on your own is better. Like, what was the class about? Was it just Verilog or like? Oh, C. Okay, okay.
Yeah, I don't think it's. I mean, if you're learning Verilog, you have a lot of avenues to explore too. Like, you can do like FPGA stuff, if I'm not mistaken, and that's like if you want to get into quant, that's like super useful, no?
What's get into what?
But sorry,
What do you want to get into?
into quantitative.
Oh, yeah, yeah, okay, yeah. It's very specialized field, very competitive too.
Yeah. So if you're learning Verilog, that is like super useful um for basically everything in quant is done on FPGAs. And you can only code FPGAs through Verilog. So Verilog is going to be very lucrative, or it already is very lucrative, but it isn't something that a lot of people will get a chance to explore or um, mandatory. Yes, but you're also going to need to know a lot of Verilog. The quant is a very specialized field. You make a lot of money. You need to know C++, you need to know Python, you need to know Verilog, you need to know how embedded systems work, you need to know how quantitative algorithms work, you need to like math-wise, you need to be a complete wizard. Um, and you need to know how the computers work.
Yeah.
So if you can get a good grasp of all of that, congratulations, you've made yourself a multi-millionaire.
By the way, I don't
Should
think
I?
that's sorry. Go ahead. Sorry.
Yeah, you should answer this one.
Yeah.
I'm getting
But
cooked myself still.
by the way, you don't have a quant developer from New York, so like if you're the first one to do it, then congratulations. Like we need a quant, bro. We need to make York better as a as students. I just have a quant guy from New York.
Exactly. A quant
She's
workshop would go crazy.
yeah, yeah, yeah. Sorry, I skipped your question. So regarding grades, should we? I feel like I mean, yeah, that's also me. Uh, like for a great GPA, I think it has some advantages. So like if I mean obviously if you want to do grad school, then like yeah, by all means do like have a great GPA. But like if you want to also apply for internships, like a high GPA can like signal you to recruiters as a smart person, but like obviously it's not really required. So like I definitely wouldn't like neglect GPA, but at the same time, um, I, it doesn't really matter that much. Like I think GPA like matters for me if like you don't get kicked out of uni. Um, and I'm not in CS, so like I'm not very familiar with like how honors, non-honors works. and like I also suck at tests as well, and the material is just like it's nice to learn if like you're doing stuff on your own, but like it's just prof dependent. So like you kind of have to like plan like smartly of how you take your classes, and it's just more of like how to like explore your interest in all that stuff. So that's basically it.
Yeah, I will say, like, I got a lot of nice props too, but usually what you're gonna see online about nice props is they're gonna make like ridiculously hard tests. So if you're good at test taking, um, that is a completely different skill set in than being good at programming, right? So like I myself am like barely surviving. I'm like right at the cusp of getting kicked out of the program as well. Um, so yeah, I mean, I would say grades certainly do matter in the sense that um, if you get it in class, um, it's not guaranteed that you will get it on like in practicality as well, but it certainly helps a lot. And same vice versa, right? But it isn't always the case. Like generally 80% of the time, yes, 20% of the time, no. So I wouldn't be too stressed, but of course you know yourself better than I do, so um I wouldn't be able to help you much there. In Rust, useful in cybersecurity? Yes, very much so. So um, that is what the whole philosophy of Rust is writing safe code, writing memory safe code at the cost of um, user comfort. Let's just say at the cost of the comfort of the developer. Like I've been working with Rust for like about 2 years now, and just in writing like a simple HTTP server, I like struggled in front of you guys for like 20 minutes, right? But that is just how Rust is. Like no matter how experienced you are, no matter how long you've known the language for, it's gonna cook you every single time. But you have to know that you're making it that trade-off. You're sacrificing your ego or your comfort as a developer to make like actually safe code. So in terms of cybersecurity, everything that you make in Rust is going to be inherently a lot safer than everything systems level you're going to make in any other systems level language. But of course, that is not to say that Rust cannot have bugs or Rust is inherently like completely locked and completely secure and it's unhackable. Of course, Rust cannot stop you from making logical errors. It cannot stop you from making logical mistakes, but it can help you in terms of memory safety, memory tightness, and a lot of these like malloc bugs, a lot of these race conditions, data races, and a lot of these bugs that are like basically skill issues for C devs. Um, so yes, Rust is very useful for cybersecurity. Right. Any more questions? Specifically about Rust, about um, web servers, about web dev, about systems dev. I think we should wait until 3:20, and then we should wrap up.
Mm-hmm. Yeah, we're at 2 hours and 5 minutes. Pretty long, eh?
Yeah.
Yeah.
I mean, technically, we ended the session. We're just having like an
Yeah.
after part.
Mm-hmm.
Um.
Oh, I appreciate it. I'll
All
see you
right.
there too. Have
Yeah.
a good
Thank
one,
you.
buddy.
Hope you had fun.
Bye bye. Appreciate it.
Thank you. Thank you. Oh, we got the recording, right? Is that
Yeah,
it?
yeah. I'm still recording. Yeah.
Perfect. So yeah, just so you guys know, this is going to be up on YouTube as well. If you ever feel the need to revisit it.
Hopefully by tonight I'll post the recording like here and like whatever platforms that people can access to.
Yeah, no rush, no rush. Oh, I'll also upload the iPad notes.
Okay, yeah, yeah. All right, good.
Yeah, I'll send them over in general. Making this workshop is first time discoveries. Yeah, man. I mean, there's a lot of stuff in comp sci that is like it's hard, but that is what makes it fascinating as well. Like, um, yeah. I mean, Rust is great. Rust is awesome, and I'm glad you enjoyed it. Thanks for attending, man.